Okay, so the final video, we'll just mix up the examples now. So we'll put together all the rules and a few different rules inside of each question. Okay, so again, I'm just going to whip out a textbook and just see what kind of examples we've got. Okay, so let's see, C2 times C4 to the power of a half. Again, that's quite common. Okay, so what do we do here? Yes, we've got two rules, and again, I'm trying to give you a little pause so you can pause the video if you want, have a think yourself, and then unpause when I go through it if you want. I've not died suddenly after I asked the question. So yeah, what are we doing here? So do the inside bracket first. So we've got 2 and 4. So we're multiplying them, so we're going to add the indices. Okay, so that's going to be C to the 6. Okay, I'll just keep the bracket big just to keep that in the same place. So inside the bracket, that was good to me. Outside the bracket, we're going to be multiplying. Okay, so 6 halves, so it's going to be C to the 6 over 2. Again, this goes back to our fraction rules. Okay, if we do 6 times a half, you could think on that as 6 over 1 times a half. So it's going to be 6 times 1 is 6, and 1 times 2 is 2, and that's what's going to give us 3. So C to the 6 halves, which is the same as C cubed. Okay, good stuff. Let's try another one, shall we? Just scroll down. Okay, let's go for y cubed times y to the power of a quarter. And I'll actually draw that. Okay, so just like before, again, imagine that's got a 1 up here. Okay, so adding the indices, y to the 4, and this time we've got a quarter on the outside, so 4 times a quarter is the same as 4 over 1 times 1 over 4, which is just the same as 4. Sorry, just the same as 1. 4 times 1 is 4, 1 times 4 is 4, so that's equal to 1. Okay, makes sense, doesn't it? 4 quarters gives you 1 whole, but that's the kind of the fractional way of thinking about it. So 4 times a quarter, you could write it like this, and then on your next step, you could write it like this, which is the same as saying y. Okay, that's the same. Good stuff. Next question. W to the half squared. So just like we said before, a half times 2 is going to give us 2 over 2. It's going to give us 1, and that's just the same as w. Nice and easy. Let's go for a trickier one. People always don't seem to enjoy these as much. To the power of a half. So 1 over x squared. I don't like 1 over x squared. It's quite hard to work with. What's easier to work with is x to the minus 2. Okay. So that's our rule. Bringing this up, making it a negative, and then minus 2 times a half. Minus 2 times a half is just the same as minus 2 divided by 2, which is the same as minus 1. So this would become x to the minus 1, which we know is the same as 1 over x to the 1, which is just the same as 1 over x. Okay, nice and straightforward. So just start on the inside of these brackets, do your rules, and then work your way out. And don't get flustered when you see what looks like strange notation. And chances are it'll come out as something quite sensible as well. Okay, yeah, I'm quite happy with that. Let's try another one like that. So again, lots of numbers, but still the exact same idea. X to the 8 divided by x to the 5 to the power of a third. Oops. Power of a third. So yeah, start off in here. 8 minus 5 is going to give us 3. So we'll get x cubed. We'll get x cubed to the power of a third. 3 times a third just gives us 1, so that's x to the 1, which is just the same as x. So taking away and multiplying, nice and straightforward. Right, let's try some longer equations that you probably wouldn't get anything. Maybe you would. Eventually you'll get questions like this, but usually the indices are not just as long-winded as this, I don't think. So let's say we've got 3a squared brackets 5a cubed plus 4a to the minus 2. So I'd want to do this part first, and then want to do that part. So let's look at the first bit. Okay, so we'll just look at this section in here. Okay, pardon me. So 3 times 5 is 15. A squared times a cubed. So we're timesing, so we're going to add the indices. So it's going to be a to the 5. Okay. Same again on the seconds. Second bit's over here now. Okay. Just change that pen color. So now we're looking at the yellow section. Well, for some reason it's just come out as green again. Alright, so anyway, this bit here, 3 times 4 is going to give us 12. A to the 2 and a to the minus 2. So that's going to be 2 add minus 2. Okay, so that's going to give us 0, isn't it? So we've got 15a to the 5, that's fine. But now we've got 12a to the 0, because we're multiplying these, so we have to add the indices. 2 minus 2 is 0. Anything to the power of 0 is 1. Okay, so we can get rid of this, and that would just times 12 by 1 would be 12. Okay, so that'll be our final answer. That's quite a good question. So we're doing our addition, but then that's a little tricky part in here, where it's making us remember the 0. Okay, good stuff. I've just accidentally done that. Okay, let's do another one like that. That was good fun. So let's try for 6d to the third bracket 2d to the 2/3 minus 5d to the minus a third. So again, it all looks very complicated, but we'll just do what we did before. So first thing, let's look at these two numbers together. So 6 times 2 is 12, that's fine. And we've got d, and we're going to do d, it's going to be a third plus 2/3. Okay. The next bit is the minus, and then we're going to do this one times this one. So 6 times 5 is 30. I kept the minus in there. 6 times minus 5 minus 30. Okay. And it's going to be d to the 1/3 take away 1/3. So we're doing this plus this. So a third plus minus a third is just a third minus a third. Okay. So a third plus 2/3 is 3/3, which is 1. So this is going to be 12d to the 1, which is just 12d. Take away 30d. A third minus a third is 0. So we know d to the 0 is going to give us 1. So we can just forget about this and just say it's 12d minus 30. Because 30 times 1 is 30. Okay. Nice one. Let's do one last one. Let's do 2d minus 3 over d to the power of 2. So how do we think about that? Okay, so the classic mistake to make here is to say 2d squared minus 3 over d squared. But when you have a bracket like this, you need to think on it differently, okay? Before we had what you could consider to be, say, a bracket, b plus c, and that will factor out to be ab plus ac, because you do a times b and a times c. But if you were to do b plus c squared, that's not going to give you b squared plus c squared. Okay? because b plus c squared is actually b plus c times b plus c. The best way to do this is to say, well, b plus c and b plus c, so that's going to give you b squared and c squared, but also bc and bc. Okay, so when you see something like this, I would always get your little table out. Okay, I'd always say, right, 2d minus 3 over d, and then I'd say down here 2d minus 3 over d. Okay, so 4d squared, 2 times 2 is 4, d times d, d squared, minus 6d over d, which is just going to be minus 6, yeah? So minus 3 over d times 2d, minus 3 times 2d is minus 6d divided by d. So that's just minus 6. This term is going to be the same, okay? Minus 6. Over here, we're going to do minus 3 over d times minus 3 over d. So on the top, that's going to give us 9 minus 3 times minus 3. And on the bottom, that's going to give us d times d, which is d squared. Okay. So we can rewrite that. Let's do 4d squared, which was our first term. Minus 6 and minus 6 is going to be minus 12. I'm going to write that over here. And then 9 over d squared plus 9 over d squared. So I think that was quite good, except for this part. Well, actually, I think that's probably fine the way it's written, to be fair. If you wanted to manipulate it, you could say 4d squared plus 9d to the minus 2 minus 12. Actually, I prefer it written this way, but you could do that if you were looking to manipulate the formula and you needed to move the d up. Okay, but yeah, the main lesson here is that when you have brackets that square, remember you're times in the bracket by itself. You're not just squaring the two terms inside the bracket. Okay.